Okay.
Oh, you
Um,
recorded it already. Here we go.
oh yeah.
Well, you should ask Jack and Caleb and everyone else.
Yeah, is everyone all right?
I'm
Okay.
good.
All right. Well,
I think we gotta wait for Chase though.
Chase is talking with Alex Y, and he said he's going to be a little bit late, but he's going to join. So he said to
Okay.
get started. Yeah.
All right, I'll go ahead and get started. I actually have a PowerPoint. I don't know if these traditionally have PowerPoints.
I really hope it's on lizards.
It's on something a bit more abstract. So something that I am very passionate about is first principles thinking. That is the idea that to solve any problem, most things are simple and most problems are easily solvable if you break them down into their base components. And then think about the smaller components instead of thinking about examples or like higher level things. For example, if you're trying to think about heat or like, why is it cold or hot, instead of trying to think about the air and the sun and the temperature, the first principle of heat would be that there are atoms and they are moving, and they're moving faster if they're hotter, slower if they're colder. And using that as your framework of thinking about heat is a lot more powerful than thinking about there is air and then there's sun and there's this, and like these other higher level concepts. I think a better example would be for like, let's say you want to be really good at tasting beer and knowing what a beer would taste like. One way of going about it, which I would say is a bit more naive, is to look at it from this beer was made by this company and it has this kind of flavor. Thus, another beer by this same company would have a similar flavor. And like you can kind of look at these higher order ways of thinking about it. But the first principles of what does a beer taste like would be, all right, I have taste buds and there are certain compounds in the beer. Hops has this compound. When you grill it this much, it makes the compound do this and it reacts here. So now you have a much more powerful framework of deciding how a beer will taste later, because if you know the contents of it, you can deduce rather well if it's going like what it's going to taste. But if you just know who it's made by, or like some other like, oh, it is a lager, whatever that means, and it's hard to determine what's going to happen. So first principles thinking is just breaking things down into their components and like building up from there. And I think it's a very powerful framework and you can apply it to most things. Elon Musk is a very big proponent of first principle thinking, talks about it all the time. And that's how he's able to, start new companies, because if someone says you can't do it, he's like, well, break it down to the first principles. We'll build up from there if they don't say you can't. So I'd like to talk about kind of a first principle of logic, basic, just general logic, which is actually a fallacy that a lot of the time is committed when you're just trying to think about a problem. The fallacy is called the converse error. Another way of calling it that's more technical is the fallacy of affirming the consequence. Or I think the best way of saying it is just correlation doesn't equal causation. That's kind of something that we've been told. So I'll be talking a bit about like some philosophy, but it's just really logic. But we can look right here. We have Plato and Aristotle. Plato is pointing up at the world, saying that all things originate from some higher realm, and Aristotle, who's kind of Aristotle kind of started first principle thinking, and he was like wrote about it a lot. He's pointing down at the earth to say we should look and observe things here. And then they're saying, do you even exist? And we'll kind of get into that more. But the converse error. So to begin with, I want to kind of have a framework or like something we're going to be working with here. And what it is let's say we're going on a journey where we're trying to predict how Facebook works. We know Facebook's a successful company, so we want to emulate it as perfectly as possible. So we'll go down two different routes, one that's technical and non-technical. So let's say we want to emulate their API. Facebook's API, we test it, we ask for a user, we ask for a post, and we get things back. And we're like, okay, well, we can, remake their API all the way, but we want it to be the exact same. So like, let's say we do some probing of it and we see, oh, it's kind of like slow. Why is it slow? Maybe it's coded in JavaScript. So because that would make an API slow or something. You can come up with all these different reasons. Another way you could look at it is like you see that Facebook's employees are sad, or let's say they're happy. All the employees at Facebook are happy. So you can assume that means that they're paying their employees, which is an assumption, and it's probably a good one that they're paying their employees. So in our Facebook, we'll call it Bookface, we're going to pay our employees. And then you can keep looking at pieces of data from Facebook and adjust the way that you make your Facebook to try to make them the exact same, because that's our goal. We want to emulate them as well as possible so we get the best results. And the first principles of here is like, I want to be kind of clear about what each of these terms are, because they come up all the time, and just being able to think about the world in terms of these terms is a very powerful way of thinking. So Facebook here is the truth. We want to know some truth, and Facebook, how it operates, how their API is coded, is the truth. And we can make observations of it. Observations don't give you the full truth. Facebook could be hiding some things, or like not telling you, but you can get some truth from how their API works, from press reports, talking to someone who works there. There's a lot of different ways to gather truth about it. So those are your observations. And to make our model of how Facebook works, our book face, that's just like our version of it. And we wanted it to be as close as possible to the correct version of Facebook. But to make our model, we have to make a lot of assumptions. And this is a key part. We have to know what our assumptions are. If we say that the API is slow, and we assume that it's slow because it's coded in JavaScript, that's an assumption. And the more you want to really nail down what you are assuming when you are trying to make these kind of things. So yeah, these are the important kind of like terms, and we'll keep going. So first, I kind of want to show how you would prove something. Like, we want to try to prove that our model of Facebook is the exact same. So this is a generic proof of how you would say that Mike is mortal. If Mike is a man, then he is mortal. That's a statement. That's an if statement. If he is a man, then he is mortal. It's not saying that he is a man here. It's just saying that if he was one, then he would be mortal. The second statement here says that Mike is a man. That is something we're asserting. And then this last one, it's bolded, means that's our conclusion. Mike is mortal. So if we kind of break this up a bit, we can say if Mike is a man is statement A, and then he is mortal, statement B. And we can kind of put these two together. And A, it means B. So if Mike is a man, then he's mortal. Mike is a man, A. And if you can imagine, if these two premises are true, then that means B is true. So that is how you kind of prove that something is true. You have to set up these premises and say that one, like if A is true, then it implies B is true. We're not necessarily saying that they're true, but we're saying that if they were true, then the conclusion would be true. So that means it's a valid argument. I would also probably say this is a sound argument. I think Mike's a man and I think he's mortal. So it is a correct argument. So let's go to another one. If Chase robs a bank, then he'll be arrested. Chase was arrested, thus Chase robbed a bank. Now, there's something weird going on here. We have us concluding that Chase robbed a bank because he was arrested is kind of weird. There's many different reasons that Chase could be arrested. He could have, defrauded investors, or, kicked someone or something, or publicly intoxicated. There's a lot of different reasons. So we make the assumption that the only reason that Chase was arrested is because he could have robbed a bank. And that's the only reason. So this is not a valid argument. And you can see it even clearly here. If Chase robs a bank, A, then he'll be arrested, B. And then all we're asserting is that Chase was arrested. That's our observation, which is B. And then our conclusion is Chase robbed a bank. Now we have this kind of framework of thinking. We'll bring it back to how Facebook works. So one of the predictions of our model of like how Facebook works is if Facebook pays their employees, then they'll be happy. That's an if-then statement. And we observe that Facebook's employees are happy. So we make so we put in our model that they pay their employees. So we're going to pay their employees. But we have the same error here. They could be many different reasons that they're happy. They could be, have health benefits, free lunch, whatever. But we are making the assumption that this is the only way that they can be happy. Same thing for their API. If their API is coded in JavaScript, then their API would be slow. That's a prediction of our model. Their API is slow. That's the observation that we see. We can actually see that. Then we conclude that their API is coded in JavaScript. Again, wrong. There could be a lot of different reasons that their API is slow. They could just be bad coders and coding it in C++. So there's there's an assumption here, and we can kind of fix that by putting these assumptions in. The only reason that Facebook's employees could be happy is if they are paid. So when you make this observation, and then you add this assumption here, then now your conclusion is true. Facebook pays their employees. That can be true if all of these things are true, but it's very hard to prove that the only reason that they could be happy is if they are paid. That's a really bad assumption. It's hard to tell if an assumption is bad, and we can build some tools to say if an assumptions are bad or not, but it just seems wrong. You could maybe gather some more data and see, oh, I met someone who worked at Facebook and they have a Tesla. So I could assume that they have a Tesla because they get paid a lot. And the only reason they could have a Tesla is because Facebook pays them. That's probably a better assumption, still an assumption, but you can start to like get deeper and deeper into better assumptions. But you have to know that there are assumptions to prove that your model is the same as the truth. So this whole fallacy, this error is called the converse error. We're trying to prove a converse here instead of the actual thing. This is also kind of correlation doesn't equal causation. Just because Facebook's employees are happy doesn't mean that they are the cause of their happiness is them being paid. There could be a lot of different things that correlate to them being happy, but that doesn't mean that was the cause. So then we'll go into a bit, we'll take this model and kind of string it out a bit more. So I want to go into like some bit about how science works, I guess, or trying to prove scientific theories. So if Newton's theory of gravity is correct, then things will fall down. We observe that things fall down, thus Newton's theory of gravity is correct. This is the same error, the same converse error. We're looking at the consequence, which is things that fall down, and saying that since the theory of gravity predicts it, that must be correct. That's not how you can look at these things. It's incorrect to say that this statement proves that gravity is correct. Now, there's some other, it's pretty good. It works out pretty well. But as we know, well, we can show that it's not correct because there was a better theory that came along, which is Einstein's theory of general relativity, which proves a lot more accurately how things move around and how things fall and whatnot. So it says that if it's correct, then things will fall down to the Earth. Also says that, Mercury will orbit in a certain way, or Earth will do this, or black holes or that. And it predicts a lot of things that we can see. But still, we still have the assumption that the only reason that, black holes can form and that planets can move and, things fall down is because Einstein's theory is correct. And that's a weird assumption still. Like, there's no way to prove that it's correct. All we can do is say that it seems to be correct for all cases we've tried. That's induction, saying that every time we've tried this, it has happened the same way. So we induce or induct that it is true. Induction, there's a problem with induction. There's a famous problem with induction called the problem with induction. It's just, if you say that, like every time I look at something, it's the same. There's no way of like saying that that's true. Like, so like you can't prove that the sun will always come up every morning because, tomorrow, some big asteroid could hit the sun, knock it off course, and then it won't come up in the morning. There's no way to prove that the sun will come up. We can induce that it will because it has, the past 12 billion years or whatever. But I'm going to go a bit more absurd with this and say that if Tyler's magic monkey theory is correct, then things will fall down and things fall down. My magic monkey theory is that there is an invisible, giant, undetectable monkey that is roaming around the world, that is actually moving the planets and moving everything down, pulling balls down every time you drop them, and doing this. And there is no way to disprove this. You cannot tell me that this magic monkey doesn't exist. So I claim that this is the correct way that the universe operates. Now, there's some problems with this, but one of the problems isn't that you can't disprove it. Modern scientists have kind of like looked at this, like René Descartes is a famous French and mathematician from around 300 years ago, who kind of realized this when he was doing some philosophy and was like, oh shit, we can't prove anything. And he started to go crazy and he was like, okay, how can I start to prove things in my head? How can I like know if something is true if there's all I have is perception? Like, I don't know if there's like, what he put is there's a demon shining light in my eyes and my senses and making me think that this world is true, but because all I have is my eyes and my ears and my mouth. Like someone could be, implanting stuff into that. Then he came up with the famous phrase that I think, therefore I am. The only I am means I exist. And he knew that since he was thinking about things, there must be somewhere out there something that means that he exists. He might not exist right there, but he exists somewhere. So that's where that phrase, I think, therefore I am, means like, since I am a thinking conscious being, I must exist in some form. And then Karl Popper, who's a philosopher of science in the 50s, kind of came at this and tried to say, how can we disprove Tyler's magic monkey theory? One way of doing it is by saying a good theory of science should be falsifiable. So you should be able to say if something is false. Magic monkey theory, you can't disprove. It moves everything around, and whatever you say, I say it is correct. General relativity is theorized to be disprovable. There's some things around black holes that we could observe that say, oh, general relativity isn't correct. It predicted this, this actually happened. So that is how a scientist would say a theory is good or bad, but that does not mean it's proven to be true. That just means that in the eyes of a scientist, it is more accurate than another. And we can kind of take this back to our Facebook model. There is Facebook, the correct Facebook, and then there's our book face that we're trying to build. There's no possible way to prove that our Facebook is the same as the correct Facebook. The only way we really could is if a Facebook executive wrote up everything, how every single thing worked and gave it to us, and we checked against our, oh, they use C++, we thought JavaScript, we got that one wrong, let's change that. And then we make an exact copy. But the universe doesn't do that. The universe doesn't give us a list of how everything works. We have to probe it ourselves, just like how, in our example, we were probing Facebook. So all this kind of means that you can't prove anything that you create is the same as what you're observing. And this comes up a lot. A lot of the time, people would say, oh, look at that. I observed that about the wall, or I observed that about this company. That means they must be doing this. And that's a logical fallacy that we make a lot. All it means is that they have that consequence. There's a lot of different things that could make that. There's a lot of different reasons Facebook's employees could be happy besides just being paid. And just to kind of put this into perspective is a very powerful way of thinking. Something else to point out here is if you've heard of a scientific law, this things fall down is a law or an observation. Laws and observations are the same thing. They're just things that we can observe. We know our observations are kind of true because I really do observe that Facebook's employees are happy. That is a true thing. I do observe that things fall down. That's true. Now, the theory underlying it, why things fall down, that's what we can't prove to be true. But we can prove that our observations are true. So then to end this, I would like to talk about the allegory of the cave, which is Plato's way of kind of looking at the world. Plato was a famous Greek philosopher taught by Socrates. He wrote a book called The Republic, where he kind of outlined this allegory of a cave, along with a lot of other things, like talking about how to make an ideal society, what justice means, and all these topics. But in it, he outlines a cave. Now, in this cave, there are some people. Give me 1 second, I drink some water. In this cave, there are some people that are chained to a wall, and all they can do is see this cave wall. So these are prisoners or something. For some reason, they're down here and they've lived their whole life in this cave. And there's some light source over here that is pointing or shining light into the cave. And if there's any object that comes in between the light source, then they see shadows on the wall. So you can see here, this guy's holding some object, and probably these cave dwellers see some weird shape on the wall. But you can imagine if they've lived their whole life in this cave, things probably make sense to them. They probably see a ball moving around, and they might not call it a ball, but they know that it is an object that they've seen before. And they probably can you start to understand things like, oh, I've seen that ball before. I kind of understand what it probably will do next. It wouldn't be the way that we understand it because we know 3 dimensions. They only have these 2-dimensional shadows that they see of the world. But you can imagine that they would start to make these observations about it and then generate models about it. Like, oh, well, their models would be a lot different than ours. But for example, a model of a ball, right now, the ball is the same size. But if it gets closer, it gets bigger on the wall. If it gets further away, it's smaller. So whereas in our world, we think that shapes have the same, take up the same amount of space. In their world, when they look at this cave wall, things get bigger and smaller, like the same objects. So they don't have the conservation of mass that we do. Things can change size and move around. You can imagine a cube moving around looks really weird to them because things can move and get bigger and smaller. And if you have 2 things, one that's further away than another, and they pass over each other, then they could have, 2 things could occupy the same space, which that's not possible in our world. 2 things that, things hit each other and bounce off, but things wouldn't bounce off in their world. So you can imagine the models they have of the universe are much, much different than the ones that we have. So bringing it back to these definitions, there is a ground truth. A truth is the real world. This guy holding up a chair, people walking in front of the cave, casting shadows. That's the real world. They make observations on this cave wall of the shadows. and then they make assumptions based on those observations of how the world works, and they made their own models of physics, of how things move around, how things work. There's a whole nother story that goes with the cave, but we won't go into it right now. But the point I want to kind of bring up here is they can't prove that the cave wall is true. And you can imagine some Einstein that's chained there can prove, can start to deduce that maybe there's a three-dimensional world out there. But that's a hard thing to do. Just sitting there and seeing these do things your whole life and deducing that there's a three-dimensional world that's just a shadow. That's hard. That's a hard thing to conceptualize. But so they have this model and they can't prove that it is correct. And they may or may not know that, but they can know that things could be different. And the obvious consequence of this is where I would like to end, that we are actually in a cave. Everything that we see around the world, these objects and whatnot, are probably just shadows or some kind of projection from some giant 4-dimensional, 5-dimensional, whatever universe that just looks like, because the way that we have been born and been observed and looking at the world our whole life, our biology makes it look like there are 3 dimensions of space and 1 of time, and that time moves forward and all these things. But there's no way of proving that. There's no way of proving that time exists or that we have to live in 3 dimensions of space. I truly believe that these are just derivations or just projections from some bigger space of some universe that just doesn't make sense, that we can't even comprehend. And because there's no way of proving that any of our theories are right, there's no way of proving that there are 3 dimensions of space or that these things move. And I think that's just a powerful thing to think about, that nothing is provable. No, you can't prove any observation is the same as the truth. And there's signs today in physics that general relativity is wrong, that maybe space doesn't exist, time doesn't exist. These are just things that emerge from some very simple, maybe even complicated process that just looks weird. So yeah, I wanted to kind of explain this framework, the converse error, and kind of make this framework of a model and observation, assumption, and the truth. And because I think it's a very powerful thing. It applies to almost every time you're trying to solve a problem or you're trying to figure something out. And if you can kind of break it down to these first principles of how it works, it's very easy to start to work with it. It's a lot easier, instead of just having these more abstract concepts, having concrete, there is a truth that I'm trying to find, and there is a model that I am building, and I am building it off these assumptions. Know your assumptions, write them all down as your premises. If you look at your assumptions, you can poke at them and say, oh, this is my assumption. I know that this is an assumption. Maybe this is where I should look to find something new. For example, one of our assumptions is that we live in 3 dimensions. That's a problem, in my opinion, probably not a true assumption that we live in this world, and that's somewhere we can probe. But yeah, that's kind of what I wanted to go over. In short, nothing exists. Nothing is provable, but everything is still fun, and the world's kind of cool. Any questions?
This was awesome, dude.
Round of
This
applause.
was not expected. Yeah.
Round of applause.
I was gonna ask, do you feel that we get kind of caught up in ways of thinking that prevent us from being able to maybe perceive things as being that kind of thwart our creativity on how on kind of unfathomable kind of possibilities of how the world really or how reality really is. You know what I'm saying?
Yeah, there's a lot of times that I think there's some simpler examples besides reality is incorrect. There's a lot of times where you just take what someone says and now you put it in your bank of facts. Let's say I want to make a good website and someone told me that a good website has 3 colors and you only use 3 colors. So I take that assumption, I put in my bank of the facts of how things work. And now that is a part of my way I think, is this assumption. But you should always ask why. You should probe more into this assumption and get down to the base principles, the first principles of it. So users like looking at things that look good, thus this assumption that people like 3 colors is good. And that's it's a hard way to think. It's hard to look at the facts that you have memorized and say, I don't want to know the facts. I want to know the underlying principles of the facts. And then from those, see if my assumptions, like if I can derive those from those facts. So if I want to build a good website, my assumption or like my base principle that users, I want people to look here. Psychology says users like good colors, thus I would do this. And like I would put three color scheme. And then maybe you can start to prove these beliefs that you have. And even in physics in the universe, I mean, yeah, that's like an assumption that everyone, and it's very hard to break the assumption, and I don't think, maybe not even possible, that time moves forward. That is an assumption that we have made about it. If you've ever watched a movie like Arrival, it's a very interesting movie. There's aliens that come that have actually experienced all of time at once. And they have a completely different biology and a way of thinking and looking at the world. But there's no, like, we can't prove that turtles aren't experiencing all of time at once. Like that is an assumption that we have, that everyone moves forward through time. Maybe it's just our biology or the way our brain works that makes that happen. But yeah, I think a lot of times it's very easy to get caught up in your assumptions. And the more you ask why, the more you ask, like, what are my assumptions in this situation? And how can I break them to try to get a better understanding of things is very powerful.
I really like that. I do like to think that I ask myself certain questions on why things have to be a certain way to then deduce a different perspective on solving a particular problem or understanding a particular situation. And that question isn't to say that like the thing that we're doing or whatever that is wrong. It's just more approaching it from a different perspective that then might give a different way of us interpreting that particular thing. And so like questioning is a powerful tool to kind of allow you to think in a different way, which I was curious when looking at this diagram, I couldn't help but to think about my cat and his perception of the world, which in my apartment, does he know that there's things outside the world that are like tangible and objects? He certainly knows that there's birds and they're moving around and they excite him, but like, does he know like that there is vastness to what's beyond that window outside of the hallway, that he knows there is something there? So I just thought that using that and then thinking about different levels of consciousness is also interesting, just because like if you were to replace this human with a cat, you know, their questions of the objects and the shadows would be then completely different than the questions that this human has because of the levels of consciousness.
Yeah. The more, I think a key element of consciousness is being able to ask why you think something. It's not the only element, but it's a key one. And cats probably ask why they think something a lot less than we do. But we probably could use more asking why of what we think. But yeah, that's a good point.
I think as well that our language, our ability to like form language, and then because cats are not dumb, they're smart, but they don't have an ability to like articulate and create a language that they can communicate with, and then therefore share ideas, and then be able to then take those ideas and then over time, like those ideas kind of seed other people's ideas that kind of helps them create like, you know, so they might have reasoning, but they don't necessarily have language to then kind of communicate those ideas to then kind of grow the larger population of cats, like to help them evolve like mentally, you know.
Yeah,
that's a good point.
I just thought.
No, that's a good point too, because like you could almost argue that while we have a certain level of consciousness, cats may have a higher level of consciousness in other areas that we don't have. And that's certainly the case when you think about their whiskers and their ability to smell and their ability to perceive objects around them, where like, you know, in a foot, 2 feet away from their face, they're not using their eyes. They're using all of their smells and sensories to like kind of navigate where to go. And we definitely don't do that. So that's also an interesting like perspective to it, is that they might have a higher consciousness in a different area than us because of that.
Yeah, like I was listening to a podcast with an evolutionary biologist on it, and he was talking about how a bat has this echolocation that it uses, and it kind of probes the world like 60 times a second to kind of get an idea of what it is. But it has an incredible consciousness to build this echolocation into a 3D representation of the world and like move around it and whatnot. And we have no way of conceiving what that is like. Our software is fundamentally different. Even if you put a human brain in a bat, we would be getting all this sensory input. We just don't know how to work with it. Like, because their software is meant to, convert this kind of like information into a 3D model. Same with a cat, the whiskers and like all these other different sensors that they have software, in their brain to like convert it into a way of understanding the world that we just don't have. But yeah.
That's really interesting insight.
Yeah, I thought this was like kind of probably not what people were thinking, but I think it's still a very like, this is something I've been like thinking about a lot recently, just like how to understand the world in a very, I fundamentally think everything is very simple, and that you can build these very simple models of how the world works and kind of like from the simplicity derive whatever complicated thing you need. And I think this is like one of the very base principles of just like logical thinking and how to prove certain things are true or not.
I think regarding passion talks, this was fantastic. This was like definitely passionate, and then but also like we all learned something, and this was amazing. I would the one thing I would ask for is like if you want to share this, but also maybe on the end of it to kind of be like continued like resources, essentially like the podcast that you mentioned or other sort of resources that can be interesting, books or articles or whatnot to kind of continue down the path. But
yeah,
cool.
I mean, I read Plato's Republic, and that's where a lot of this started. I know you have it on your coffee table.
Yeah,
that's like Plato was a amazing thinker, and he like started to think about all these things a lot. Like, and it was like 2,000 years ago that he was thinking about all this stuff. And so it's like an Aristotle kind of picked up the torch where he left off, and like Aristotle has a work called Metaphysics that he goes into a lot of this as well. But yeah, just like this is the simple, like, now we have 19th century philosophers that are talking about like, much more complicated things than this. But I think just getting down to the basics is like where that, or the basics are what help you the most in like, your day to day, knowing if like, yeah. But
I've been doing Einstein's biography from Walter Isaacson.
Yeah.
And
Mm-hmm.
a lot of stuff kind of comes up there too.
Yeah. He talked like, yeah, Einstein is like the go-to example and like these kind of theories, because general relativity you can't prove, as I said, but there are a lot of like, the way that he went about showing that it's probably correct is where a lot of our thinking about how, like, we've shown that you can't prove anything, but there are ways that you can arrive at a model that's more provable or probably closer to it. Falsifiability is one of them, saying that is it possible to prove this wrong? That's something that Einstein kind of like, he didn't come up with it, but he was the golden example of, because he came up with a theory with no data. He didn't experience anything, or he didn't go and probe the world to make general relativity. He just did the math. He derived it from some basic observations. Then he went out and said, my theory predicts this. I'm going to see it. If it doesn't, it is wrong. If it does, it is right. My magic monkey theory does nothing like that. It's not science, but general relativity is science because it did that.
Right. No,
so when you make a model, try to make sure it's falsifiable. If you make a thing about Facebook, like you're trying to remake Facebook, make sure that you're like, don't just say it's using a programming language, say it is using JavaScript, because that can be falsified, But yeah. Any more questions?
Tyler, you brought up you basically said like the reality is not real, but then you were talking about Descartes, like I think therefore I am. So like what do you think about like those two things, because you are thinking right now?
Yes. Okay. So there is something. All I can say for certain is that something somewhere exists. I could be on a simulation. There's this concept of a Boltzmann brain, that there's just a brain out in the middle of the void that is thinking all of this. It is just a brain that is thinking all these concepts, and that I could be a part of Boltzmann brain or something, but something has to exist somewhere for me to be thinking. Like I could be simulated or not, But where Descartes, so that's what Descartes said. My think about nothing exists. That's kind of facetious. Something exists, but the point is that the way that we experience reality with like 3 dimensions and time moving forward and whatnot does not have to exist. That is a formulation of how we perceive the world. So that's the part that doesn't exist. Now it could be something like, you could easy examples, Matrix, that's the Matrix is how the world actually is. So that is what exists. And my formulation of how things work doesn't exist. If that kind of makes more sense. Something exists. Yeah. Something exists somewhere.
Yeah, it's interesting.
Yeah.
Something that I want to go more deeply into, but is Einstein's kind of investigation of reality, like what reality is, and like anyway, but yeah,
something really interesting about it is that he like there was no principle, there was nothing that says that reality needs to be predictable. And for the longest time, up until like the Renaissance, we didn't think reality was predictable. We didn't think you could write an equation to describe how a ball will fall. It just does it. There's no predictability about it. Why should things be predictable? There's nothing that says like anywhere that's written in the universe that math should always hold. But Einstein was amazing because he just did the math. He just derived from my understanding. He was very first principles. He said one of the first principles is that, things move. And then another one is that just like space exists. And from that, he derived all of this time, like general relativity and whatnot. And just like from as little assumptions as possible, he tried to like keep all of his assumptions out and just do the math and run the computation. And he came up with a theory that happened to also describe the universe. So that says something, that there's something crazy going on underneath of how the universe works if it's mathematical, because that does not have to be the case. You can imagine a religious view of the universe would not include math. Like it was just God is what makes things work and makes things move around and whatnot. And there doesn't need to be any math there. He does what he wants, and just to say religion is the exact same kind of argument here. Science and religion have the same way of proving things. Now science has other mechanisms in it to like make their models a bit more accurate or precise or like probably true, but it's the same kind of deal with this converse error. Einstein
married his cousin.
Yeah, I think he divorced her too, or she died or something. I don't remember. He was a kind of a promiscuous guy.
Yeah, this is awesome, Tyler.
Yeah, any more questions? I think we're over. Yeah, we're like 9 minutes over. I'm sorry, but yeah, I get kind of caught up in this. I like this kind of stuff.
It's been awesome, man.
Who's doing the next one?
Oh, that's a good question.
Here, I'll stop sharing.